Welcome back for Mr. Jeffrey's Algebra 2 class. We are not really growing. We've been at 52 subscribers for a while. So if you're here, just check it out. Go ahead and hit that subscribe button, hit the bell, hit the like. Okay, so this may be kind of difficult to record in class because we actually have a test tomorrow over this stuff, and now everybody is going to pay attention over stuff they hadn't paid attention to in the past week and a half. So, all right. So for part one, factoring completely, I haven't really decided how I'm going to do the point system on this yet or not, but we will see. All right, we always want to look. Well, yeah, I just totally misspelled GCF, so this is going to be very awesome today. All right, so shh. Now, if we look at it, what is one thing that all three of these have in common? An X. So if we divide that out, all right, now this is where we need to think about this. All right, let me get my dot here for people to follow. Let's see. Ooh, it's a daisy. All right. So this positive tells us our signs are the same. This tells us they're both negative. So what two numbers we know will multiply into 10? 5 and 2. So they would both be negative. So what is negative 5 plus negative 2? Negative 7. Yes. Remember, use of calculators are encouraged on the test. All right. So because if you multiply negative 5 and negative 2, you get 10. So again, if you multiply negative 5 and negative 2, you get positive 10. When you add negative 5 and negative 2, you get negative 7. This is the same thing you had in my class, Miss Olivia. Yes. Yes, stop oxygen theft. Now, so that's number one. Okay. Kind of, getting ourselves into it and stuff. I'm actually having trouble finding some of these larger things to factor, so it may not be as difficult as y'all think. All right. So, moving on. Wait, go back. I forgot. My bad. I forgot. Okay. Yeah. So, yeah, this is a lot of common sense. So, some of y'all are going to be kind of out of luck on this one. Okay. Uh, our two things. I wish I could throw things at students. And second thing, I really wish I could use my arm to throw. All right. So, somebody said, oh no, how do we do the next one? Well, let's think about it. Let's start with the GCF. So, what is the biggest number that we can take out of 3 and 75? What is the smallest exponent between 7 and 5? Like I said. All right, so we divide this out. We're actually left with n to the second power. All right, 75 divided by 3 is 25, and the n's go away. Awesome. Now, this part right here, this is the difference of two squares, or like we like to call dots, 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 dots. Difference of two squares. I just said it before I did the dance. Because n is a perfect square, 25 is a perfect square. Then you stop. Two squares. Oh my gosh. The newest horror movie is called Teaching Algebra 2 in High School, starring Mr. Jeffries, and he's the only victim. Okay, so the square root of n squared is n. Yes. Okay, the square root of 25 is 5. Y'all all get it right if you just copy down the answer as I do it. So, roll tide. Yeah, some people can learn by not writing stuff down. I have to look at it, rewrite it, and rewrite it again. And yeah. So, all right. Are we good with number 2? Yes. Okay, moving on. Shh. All right. So, I'm hearing lots of stuff, some of it math. I heard the greatest common factor would be a 8 and an m to the third. Yeah. Okay. Now, once we divided that out, we now have this. So now this is really hard, so I need y'all to put on your thinking caps. Okay, hang on. Please let me finish talking. All right. So this positive right here tells us our signs are the same. This tells us they're both negative. I wonder what are the only two numbers that you can multiply and get 1. Yes. Shh. All right. As I just said, this tells us our signs are the same. This tells us they're both negative. So what are they? What's the only factor of 1? Either one of these is acceptable as an answer. Okay. Yes. The good thing about being me is teaching, reviewing right before a test is like teaching the whole unit all over again. It's this. That's why I'm trapped in this loop. It's like Groundhog Day, but teaching. It's the same stuff all the time. Okay. Are we good with number 3? Shh. You have said that for every problem right before we've done it. Okay, so this tells us now, this right here may or may not be on the board tomorrow. Depends on how nice people are today. We have done this for a while now. Yeah. Okay, I do need somebody to help me out so I don't have to get off camera to plug in my laptop. All right, thank you. Don't get shocked. If you do, we'll ask if you're okay before we laugh. Okay. Wait, that's the wrong end. Yeah. All right. So the difference of 2 cubes. All right. And if you actually go into Schoology and you look at the video from what we did on Friday, bless you, there's actually a video of us doing problems like this. Now, for those that checked out Mentally Friday, this is new to you. All right. So we have to write this. What is the cube root of x to the third? Well, it's just x to the third. Okay. What number, when you multiply it by itself 3 times, is 125? Shh, it's 5. Because 5 times 5 is 25. 25 times 5 is 125. Okay? Now, shh, I promise if you are quiet and listen, we'll get it. Okay? So, this is our A. This is our B for this stuff right here. So all we have to do is rewrite it. So the first one is just x plus 5 in parentheses. Awesome. Too easy. Okay. The next one is a squared. Well, a is x, so this would be x squared minus x times 5, which is 5x. Somebody just asked where we got the 5 from. Some people need to have a cranial rectomotomy. Okay. The 5 is the cube root of 125. If you actually go back and look at this video, like 20 seconds before this, I explained that. What? Because I needed it to break down into this form so I could do this. Okay, look. Here's the deal. You have to find the cube root of this, which is x. You have to find the cube root of this, which is 5. This gives us our a and our b, and then we plug it into this formula. That's it. That's as far as you go. It's actually not as difficult as people are making it. It is not. It is not rocket surgery. Okay. Rocket surgery is like more intense than rocket science and brain surgery together. Well, if you have to uh, re-engineer a rocket, then yes, because you got to take it apart, and hence therefore that surgery. Shh. Okay. We've been on the same slide for forever. This is no. No, quit singing the song about pulling the feathers out of a lark. All right. Number 5. Okay. So this is a difference. It means there's subtraction in between those things. Wow. Just like this one was the sum because it's adding. So, oh my gosh, everybody just sounded like they were reading their Cheerios. Okay. So, if we think about it, what is the cube root of a to the third power? Yes. Okay. Now, what is the cube root of 216? What number times itself 3 times is 26 times itself 3 times is not 216. 18 times itself is 3 times 6. Thank you. Yes. There is a way to use the calculator to find the cube root. It would be 6. So, that would mean that our a is actually a. So everywhere we see a, we're going to plug this into right here. Okay. That means our b is 6. So everywhere we see b, we're going to plug in a 6. All right. Ready? I mean, yep. So this becomes now a minus 6. Okay, it says a squared. Well, that's actually a, so that's easy. A squared plus, I wonder what 6 times a is. 6a. All right, we got one. And now we have to say 6 squared. So 6 times 6 is, yes. Where? Which one? There's 16 a's out here. That's a squared. Okay, so that was number 5. How was it different from number 4? The numbers change, the variables change, and there was a subtraction. That's it. I'm following this form. I know y'all don't have this form on your paper, but you have it in your notes that people probably didn't look at as you were trying to do this. Yes. I previously said that these formulas may or may not be on the board during the testimony. Okay. All right. Oh, no. No, the table's not broken, but. Oh, my gosh. Be a teacher, they said. Change lives, they said. Get an aneurysm at work, they said. Okay. What is going on? All right. So it's the same thing, except this time we actually have a number right here. So we need to find what number times itself 3 times is 27. Now you could also use a calculator to find the cube root of this. Let's see. 9 times 9 times 9. Nope. This would be 3. Okay. 3 times 3 is 9. 9 times 3 is 27. Okay. This is going to be our A for this one. Okay. Now, we need to find the cube root of 8. What number times itself 3 times is 8? 2. And no, 2 to the third power is not 6 because this would be 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. Okay. Now, this is our A. So everywhere we see A, we're going to plug this in. All right. So this, we're going to have 3x minus 2. That covers this part. Okay. All right. This says A squared. So what is 3x times 3x? 9x squared. Yes. Okay. This says A times B. So we're going to have 3x times 2, which is 6x. And then this is our B squared, which is 2 times 2, which is 4. So this is our answer. So hopefully nobody asks, so is what circled in stars our answer? Because, I mean, stop. You're not one of the usual suspects that will ask that question. I have about 6 usual suspects, and you are not on the list. Put your hand down. Okay, so are we good through 1 through 6 now? So we're waiting patiently as everybody else writes down. This is kind of a waiting game. This is where I like to have a little chat with the people at home to make sure that everybody's listening the first time. All right, are we good now? Are we good now? Can I move on? Y'all don't give the thumbs up with your middle finger, by the way. All right. That's the joke, guys. That's the joke. That's okay. So some people are like, you can't give a thumbs up with your middle finger. So, just whatever. All right. So this is what you do right here. Shh. Everywhere we see X, we're going to plug something in. Yeah, we do have a lot of X's. Now, what we plug in is the opposite of this minus 2. So what is the opposite of minus 2? Okay, and then we use a calculator. Why do we use the opposite? Because when we were going over this the first time, it was like when we did synthetic division, where we had to do the opposite in the timeout box. No, it's shh. I'm fixing to come over there and break more than some of y'all's tables. All right. Here's this. There's the normal x. Shh. Yeah, see that right there, right there, right there. Yeah, I just put a 2. Just put you right there, right there. Okay. So minus 2. See, they think this is funny, and when they start seeing that large vein pop out of my forehead. Now, if it equals 0, what is it? I heard it. If this equals 0, then we just circle yes. Guess what? If it doesn't equal 0, what do we circle? No, and we circle it. We're not going to underline it. Okay, I will make sure it says circle. Be- Shh. What is what? Because the directions say so. Yes, it has. Yes, for the 18th time, it has to equal 0 to circle. Yes. If it doesn't equal 0, guess what you circle? There's 2 choices. You don't put maybe and circle that. This ain't a note in elementary school. Shh. Oh, I'm fixing it and oh. Now I know why some animals eat their young. So, this time, what are we going to be plugging in? A 7. Bless you. I wish y'all could hear some of my students sneeze. Sometimes they sound like small animals. Unlike me, I sound like I'm calling the rest of my elephant brethren. Okay, guess what we get when we type this in? So, we didn't get a number that was 0. Here's what's funny. Some of y'all are joking about circling or, and y'all are going to forget to not do that on either test, and you're going to miss it just for, being a hemorrhoid. So, discord is the opposite of happiness. Okay, this time, what are we plugging in? -8. That's funny. We're clapping because we thought somebody was getting a number to help them for tutoring, but the guy says it's okay because I have a girlfriend. So we were actually clapping for that person. Sometimes I have to fill in the viewers at home. Okay, guess what we get when we type this in? So this is what's funny. This is like the thing y'all see on the Tic Tac. This is, what Pokemon is it? And they go, Pikachu. And they're like, no, it's something else. They go, ah. Yeah. Well, I have to edit it for what? It's the opposite of, you see how I've got these things underlined on all three of these problems? I'm going to, oh my gosh. Okay. So, hey, after y'all, hey, can we put a timeout in learning about this person's relationship? Okay. What is the opposite of +5? Yeah, you got to do all of them. It's a new concept. +29, parentheses, -5, -13. Okay, good deal. All right. So, yes. So, what did we get for this? Okay, I got -8, but either way, this would be a no. Did you just, is that really what you got? Okay. Maybe I didn't type something in right. Okay, thank you. All right. Okay, so that's how you do 7 through 10. Okay, that's how you do 7 through 10. All right. So moving on to the back. Oh no! Finding the zeros. Okay, first thing I need you to do is to put an X right here behind 12 because Mr. Jeffries forgot it. Yep. Thank you. All right. Now, this f of x changes to a 0. That's cool. Now, what can we take out of each of these equally? Yeah, we couldn't until Mr. Jeffries fixed that typo. Yes, it was actually a typo. So I get x squared minus x minus 12. Okay, now, so, all right, are y'all ready? Because this is kind of something people didn't listen to on the first time. This negative tells us our signs are different. This negative tells us our bigger number is negative. Okay? So, what numbers do we know multiply to give us 12? Okay, so this would be -6 and +2. What's some other ones? Okay, -4 and 3. All right. So, what is -6 plus 2? -4. Okay, so this one is not going to help us. All right, what is, yeah, this is our one that we need. So x minus 4, x plus 3. Now, before anybody asks, yes, it does matter where you put the positives and negatives. Again, it does matter where you put the positives and negatives. Yes. Yep. Yep. Yes. No. Just it's gotta, it has to have x minus 4. Yeah. No. Now, couple of ways you could do this. You could cut these because remember, any of these, if any of these equals 0, the whole thing equals 0. So you could set it up like this: x equals 0, x minus 4 equals 0, x plus 3 equals 0, and solve them. Or you could do the shortcut that I told the other day, which would be funny because not a lot of people knew. All right, it's just going to be 0 right here. Okay. What is the opposite of -4? What's the opposite of +3? So there's our answer. Okay, so that's how we do this one. So for the student that said, yes, part 3 is very similar to part 1, just with zeros. This is very true. I really wish they'd quit yawning because now I'm yawning. Chicken butt, what? Good. I'm glad you're doing your work. Hang on a second. I'm fixing to have to call my elephant brethren. Nobody come over in this area. It's kind of germy. Okay. Okay. So, are we good with number 11? Okay, even if you missed this, you could quickly take a picture if you need to, or you could look back at Schoology with the completed notes is up there. No. Yeah, the final answer is these 3 numbers that are circled. I worked it out because some people didn't know why I got the opposite. I had to prove myself. Yes. Shh. Okay. So, shh. Y'all hang on. The question about the 0. We are trying to find the zeros of this thing right here. Okay. So, that means any one of, where's my little dot? Go away, you. There it is. If any of these equals 0, guess what? The whole thing equals 0. Okay, so think about it. Well, what would make this 0? A +4. What would make this right here 0? A -3. What would make x 0? 0. It's just that easy. Yeah, but yeah, it is 1x, but what can you plug in for x that will make it 0? What's 1 times 0? 0. Okay. All right. Number 12. Shh. Number 12. What's something we can divide out of everything? Yep, 2x squared. Wow, this looks kind of similar to a problem we had before. Some people are like, it does. I don't think we've ever done this problem. All right. So, now, this tells us our signs are the same. This tells us they're both negative. What 2 numbers do you multiply to get 1, but you add to get 2? Yes. All right. So, if we were to split these up, remember, because all this is multiplying, would we have to do both of these? No, you'd only have to do one. Okay? Now, what is the only thing I can plug in over here? Wait, where's my dot? Over here for this to be 0. 0. Yeah, that's the easy one. What would be, what could I plug into here to make this be 0? Positive 1, the opposite of this. Or if you had to solve it, bam! That's it. And we're like, wow, that wasn't so bad. No, it wasn't. Huh? Yeah. Really awkward when you say the wrong state. Yeah. A lot of people, their state they're in right now is not Alabama, it's confusion. Now, all right. Number 13. Okay. So, a couple of ways that you can do 13. Now, this has nothing to do, this is a method. You don't have to do this method if you don't want to. I will do the method for this one, and the other method, factor by grouping, for the next one. Okay? Shh. I hate boxes. All right. So, now I've put them in those boxes. We'll do the other method for the next one. Shh. What is the GCF between x to the third and 2x squared? Yep. Now, because this is a negative out here, I got to factor out a negative. What is the G? Huh? 16. Shh. How do we get what? Because we're finding the GCFs of the rows and then the columns. All right. What's the GCF between x to the third and minus 16x? X. Okay. Now I've got to have a negative right here because that's a negative. What's the GCF between 2 and 32? 2. All right. So I take this. Now, a couple of ways that you could actually take this and solve it. You could continue to factor, or if you wanted to, you could cut it right here and have x minus 2 equals 0 and x squared minus 16 equals 0. All right. If we did this, we would add 2 to both sides. So we get x equals 2. Awesome. Okay. Now, over here, we would add 16. So we get x squared equals 16. So how do we get rid of that x squared? Square root. So when we take the square root, what is the square root of 16? 4. But what do we need to write in front of the 4? A positive and a negative, because positive 4 times positive 4 is 16, negative 4 times negative 4 is 16. So our final answer is this right here. Yes, you have to put the plus and minus, because if not, you're actually not labeling all the zeros. The direction says we're finding the zeros. This is basically where we're finding the x values where y is 0. The x-intercepts. We're finding the x-intercepts. Huh? Yes, what two numbers can you multiply by themselves and get positive 16? Well, positive 4 times positive 4 is 16, and negative 4 times negative 4 is also 16. So that's why you have to write the plus and minus. Okay. Now, we're going to do this one by the old school method of factoring by grouping. First thing we do is put these in parentheses. Now, we have to find the GCF between x to the third and 9x squared. X squared. So we would set this as x squared times x minus 9. Okay? Ooh, that's just. Hang on. Okay. This doesn't work out right. This doesn't work out right. If you rewrite it, it does, but it doesn't. Hang on a second. No. All right, we're going to skip this one. This one doesn't. Something about this doesn't smell right. It could be a typo. I could have accidentally put 27 in there too many times because that shouldn't be that. Okay, number 15. Shh. Determine the finite differences. So, first thing we got to do is find the first difference. And 63. No, I just wrote skip up there. I'll double check the ones for the test. Okay, we did the first difference. None of them are the same, so we have to do the second difference. So, what? Shh. All right. Listen, remember, when you're not here, it's up to you to go back and look at the stuff in Schoology. All right. What we're doing is we're finding, let's see, how do I get from what's 3 minus 1? 2. Okay. Now, we go until we get all the same numbers. So I get 1, 1, 1, and 1 here. So, which difference are they all the same? Third. So this is a third degree. Now, that's the answer. We could take this data, plug it into a polynomial regression thing as long as we knew the degree, and it give us the actual polynomial for this. Okay? Now, 16. So let's see. 2 minus negative 3. This is 5. This is 6. This is 7. What? What? On the second row, the green. What's 4 minus 2? What's 7 minus 4? What's 11 minus 7? 16 minus 11. 22 minus 6. Okay. Those aren't the same, but this one is. So this is a second degree. Yeah, take the pass. All right. Thank you for my 50 something subscribers. Sorry that you had to bear with us through this because it was annoying. Good stuff, good things. Roll Tide.